chapter number 2, and chapter number 2 is structure of atom. So actually A is equal to mass number A equal to number of protons is Z plus number of neutrons. So that implies number of neutrons equal to A minus Z. Okay, and an element is represented as X, Z, either write it here or this is actually Z is atomic number, A is mass number, and X is symbol of the element. So these are the ways to represent an element. Okay. So now there are few terms like isotopes. You know that isobars, isonucleons, and isoelectronic species. These are most important in structure of atom. Okay. Isotopes, isobars, isotones, and isoelectronic species. Isotopes are elements same atomic number but different mass number. For example, isotopes of hydrogen, 1H1, 1H2, 1H3. 1H1 is called protium, denoted by P. 1H2 is called deuterium, denoted by D, and 1H3 is tritium. So these are isotopes of hydrogen. Isotopes of carbon, C12 and C14. Sometimes we write it as C12, C14 because you know C has atomic number 6. Because if it is written C, that is atomic number is fixed. Okay, so these are isotopes. Then come to isobars. Yeah, isobars. These are different elements having different atomic number. Yes, and same mass number A. Okay, for example, calcium and calcium is 20, 40, and another element having atomic mass number 40. Yes, tell me. potassium. Okay, even argon in some cases it is 40. Okay, so with isotope of argon, if it is 40, then these are isotopes: calcium, potassium, argon. Okay, so these are isobars. Now come to isotopes. See, isotones, these are elements having same number of neutrons, or we can say, have same value of A minus Z, because A minus Z means number of neutrons, so those are called isotones. Any example? For example, 6C14, 7 and 8O16. So these are isotones, because 14 minus 6, 8, 16 minus 8, 8. Okay, so these are isotones. Most important part, isoelectronic. नाम से clear है. Iso means same, electronic means electron. So species having same number of electrons. The atoms or ions having same number of electrons, those are called isoelectronic species. Either the atoms, ions, group of atoms, molecules. Okay, for example, neon. So F negative, O 2 negative, N 3 negative, or Na plus, Mg 2 plus, Al 3 plus. All of them have same number of electrons, because you know neon has 10, fluorine 9 plus 1. Negative means electron is gained, positive means electron is lost. Okay, so 9 plus 1, 8 plus 2, 7 plus 3, yes, 11 minus 1, 12 minus 2, 13 minus 3. So all have 10 electrons. So they are isoelectronic species. Same argon A plus, calcium 2 plus, scandium 3 plus, chlorine minus 1, sulfur 2 negative, phosphorus 3 negative. Again they are isoelectronic species. All have 18 electrons. So these are called isoelectronic species. Particle. Okay. Here it is mass number. Then atomic number. Protons, First is nitrogen atom, calcium ion, oxygen atom, bromide ion. Okay. And bromide. Okay, this is the table. In this table you have to fill these masses. This is 16, 20, 8. Proton you have to fill 7, 20. Here you have to fill 45. Electron 7, 36. Yes. So fill it. It is your task. Okay, start. You know calcium is as per your 288 2, so it will lose 2 electrons. Get this 288. And bromine, you know halogens, they will gain only 1 electron. Okay, so the bromide ion is actually, can we write here? Yes, Br negative. This is simply oxygen. This is calcium 2 plus. This is nitrogen. It is neutral atom, so number of electron equal to number of protons. So it is 7, and number of neutron plus number of protons is equal to mass number, that is 7 plus 7, 14, and atomic number is same as that of protons. Calcium 20, protons 20, right? So 20 plus 20, mass number is 40. Okay. And what about electrons? Electrons, because it is calcium ion, so out of 20, because total electron it has 20, but 2 electrons are removed. So it is 18 now. Calcium 18, in calcium 20 electron, but calcium ion is there. So in calcium ion there are 18 electrons. Okay. What about bromide ion? See, electrons are 36, but Br is -1. So obviously its protons are 35, and so is the atomic number. So proton plus neutron is mass number. It should be 80. Got it? Graph. Oh, this oxygen. Mass number is 16. Atomic number. So is the number of protons. So 16 minus 8, neutrons are 8. And electrons are also 8, because if it is neutral, then atomic number, protons and electrons are same. Neutrons are same by coincidence. They may be different, but atomic number, protons and electrons, they are same for a neutral atom. Next topic is electromagnetic radiation. Electromagnetic radiation means the radiation which are associated with electric and magnetic fields which are perpendicular to each other as well as to the direction of propagation. The radiations which are associated with electric and magnetic field and these fields are perpendicular to each other as well as to the direction of propagation. ये देखो ऐसा, this is one, let us take magnetic field, electric field, and this is direction of propagation. So all the three are perpendicular to each other. That is called electromagnetic radiation. Means electromagnetic radiation is one which associate itself with electric component and magnetic component. This electric component and magnetic component are perpendicular to each other as well as to the direction of propagation. Okay, and that is called electromagnetic radiation. Okay, done. So what are the properties related to it? Electromagnetic radiation can propagate in vacuum. Sound wave, you know, any other, most of the waves need medium to travel, but electromagnetic waves can travel in vacuum, and in vacuum its speed of light is speed of electromagnetic radiation, that is fixed. Okay, and they are not deflected by electric and magnetic fields. ठीक है, अब देखो जैसे properties, first property is wavelength denoted by lambda. Yes, मुझे लग रहा है most of you know what is wavelength. See, if a wave is traveling, it has crest and trough, crest, trough, like this. Okay, so distance between two consecutive crests or consecutive troughs, that is called wavelength. Distance between two consecutive crests or troughs, that is called wavelength, and it is measured in centimeter, picometer, nanometer, and so on. Okay, you angstrom, what is the value of 1 angstrom or 1 picometer, 1 nanometer? Convert 1 angstrom into meter. 10 raised to power minus 10 meter. 1 picometer, 10 raised to power minus 12 meter. 1 nanometer, 10 raised to power minus 9 meter. Like that, है ना? Okay. Now come to frequency. Next is frequency denoted by nu, and it is defined as number of waves, or we can say cycles passing through a given point in 1 second. Number of waves or cycles. Cycle means one wave, one complete cycle means one crest, one trough. Okay, this is complete cycle. So number of cycles passing through a given point in 1 second is called frequency, and it is measured in hertz. Unit is hertz. 1 hertz is 1 cycle per second, or simply we write it as per second. Megahertz, gigahertz, that you know all. रेडियो में सुना होगा. Okay, that is called frequency. Okay, now next is wave number. Wave number is denoted by nu bar. It is denoted by nu bar, and it is equal to number of waves present in unit length. Means 1 centimeter or 1 meter. That means wave number is actually equal to reciprocal of wavelength. Nu bar equal to 1 upon lambda, and its unit is per centimeter or per meter. Per centimeter means number of waves present in 1 centimeter. Per meter, number of waves present in 1 meter. Right? So that is called wave number. Okay? Now speed. Speed that you know. Distance traveled by the wave per second. Distance traveled by wave per second. Okay? Distance traveled by the wave per second. For example, and speed of light is speed of electromagnetic radiation is fixed, and that value of speed, it is denoted by c, speed of light, it is fixed, that is 3 into 10 8 meter per second. Okay, then come to next. ये हो गया अपना speed. Now amplitude. Amplitude is denoted by capital A, and amplitude is height of crest or depth of trough. Height of crest or depth of trough means maximum height. This one. This is same, capital A. Okay, and intensity of light is proportional to A square. Amplitude square is determine the intensity of light. ठीक है, number of photons passing through. Intensity means number of light packets passing through a given point in 1 second. Okay, right. So now relation between frequency and wavelength, that is very, very important. So say, what is wavelength? That is the distance between two consecutive crusts or troughs. Or one wave means one complete wavelength, one crust, one trough give one wavelength, and time taken is to complete that wave is nu bar. So lambda into nu gives C. Lambda into nu equal to C. That is the relation between wavelength and frequency. That means if you know the frequency, you can calculate the wavelength, or if you know wavelength, you can calculate frequency. These are the three relations. Lambda into nu equal to C, lambda equal to C over nu, or nu equal to C over lambda. And C you know, 3 into 10 raised per 8 meter per second. Got it? Electromagnetic spectrum is arrangement of electromagnetic radiations in the order of increasing frequency, increasing wavelength, or decreasing frequency. Right? Arrangement of electromagnetic radiations in the order of increasing wavelength or decreasing frequency. For example, cosmic rays. Cosmic rays have shortest wavelength and greatest frequency. Okay, then gamma rays, then X-rays, then ultraviolet, then visible, then infrared, then radio waves or microwaves, and last one is radio waves. So these are electromagnetic radiations in the order of increasing wavelengths and decreasing frequency. So this is called electromagnetic spectrum. Okay, so these are all electromagnetic radiations. Okay, so ये second topic हो गया हमारा. Okay, now third topic for the day is Planck's quantum theory. So first of all, what is quantum actually? So quantum is smallest packet of energy that a body can emit or absorb. That is called quantum. And in case of light, this quantum is called photon. लाइट के केस में it is called photon, right? Now, what is this theory? So according to this theory, so first postulate of this theory is any body can emit or absorb energy in the form of small packets called quantum. Okay, and second is energy of quantum is proportional to frequency. Energy, let us take E, is proportional to frequency. That implies energy is equal to h nu. E equal to h nu. H is Planck's constant and its value is 6.626 into 10 raised to power minus 34 joule second. This value is fixed. Planck's constant is fixed. Okay, so third is total energy absorbed or emitted by a body is equal to nh nu. That is E total equal to nh nu. Here n is number of quanta. Means plural of quantum is quanta, and in case of light that is called photon. Means that is equal to number of photons in case of light. Okay. Now say as E equal to h nu, that is the energy of one quantum, one photon. So the nu is c over lambda. It can be written as E equal to hc over lambda, and 1 upon lambda is wave number, so hc nu bar. So these are the relations. E equal to h nu equal to hc over lambda equal to hc nu bar, right? So now we have relation between c over lambda, nu bar, lambda into nu equal to c. Okay, E equal to h nu, hc over lambda, hc nu bar. Now on the basis of these formulas we will do some numericals. Okay, so these are three topics we have covered today. First is atomic number, mass number, isobars, isotones, isotopes, isoelectronic species, and then we did electromagnetic radiations, wavelength, frequency, speed, amplitude. Okay, and then next is this Planck's quantum theory.